In this video, we're going to see exponential growth or decay functions. Okay, first let us see what is the general form of an exponential function. That is y equals to a times b to the power t. Okay, here it may be exponential growth or decay function. It depends on the value of b. So for the value of b, we have only two options. Either b can be greater than 1 or b can be any value between 0 and 1. Okay, in the given exponential function, if b is greater than 1, then it is exponential growth function. If the value of b is a value between 0 and 1, then it is exponential decay function. Okay, and also b is called as growth or decay factor. Okay, if the given function is exponential growth, then b is growth factor. If it is decay function, then it is decay factor. What about a? So a is the initial value of a substance. That is when t is equal to 0. And what about y? So y is the amount of substance left after time t. So t refers to time. It may be in seconds or minutes or years. So it depends on the problem. So for example, if t refers to years and for example t is equal to 3, then y refers to the amount of substance left after 3 years. And when t is equal to 0, what will happen if I plug in t is equal to 0 into the exponential function y is equal to a times b to the power t? Then it will become a times b to the power 0. Then y equals to anything to the power 0 will be 1. So a times 1, then we get y equals to a. So that is the amount of substance. Y refers to y equals to a. That means the amount of substance at t is equal to 0. So that is a is the initial amount of substance. Okay, so based on what we have discussed so far, let's look at some examples. Here we have two exponential functions. Okay, first let's discuss this one. So y is equal to 100 times 1 positive 0.35t. So it is exactly in the form of y equals to a times b to the power t. So at the place of b, what do we have? We have 1 positive 0.35. Okay, if I simplify this one, what do I get? It's 1.35, which is greater than 1. So the value of b in this function is greater than 1. So clearly the first, this one is exponential growth function. Okay, and also we have to find the growth rate. So to get the growth rate, it's very simple. Just look at the value over here. It's 0.35. So let's convert this one to percentage. To convert this one to percentage, what I need to do is I have to multiply this one by 100. So when I multiply this one by 100, it will be 35%. So since 0.35 is added to 1, there is an addition sign between 1 and 0.35. So its value is 1.35, which is greater than 1. So it's an exponential growth function. To find the growth rate, you just have to take the value which is added to 1. So when I multiply this value by 100, I'm getting percentage. So the growth rate is 35%. And here 100 is the initial value. So initial value of y, that is when t is equal to 0. Okay, now let's understand the second function. So here, this is also in the form of y equals to a times b to the power t. At the place of b, we have 1 negative 0.28. When I simplify this one, what do I get? That is, I have to subtract 0.28 from 1. Then I'll be getting 0.72. This is a value between 0 and 1. Since the value of b is between 0 and 1, so the second function is exponential decay function. Okay, what is the decay rate? It's very simple. What we need to do is we have to take the value which is subtracted from 1 inside the parenthesis. Here, this is the value subtracted from 1. So to get the growth rate, you have to multiply this value by 100 to convert this one to percentage. So then I'll be getting, when I multiply 0.28 by 100, it will be 28%. So the decay rate is 28%. And again, 100 is the initial value of y. That is the value of y when t is equal to 0. Okay, let's look at some other examples. Here we have another example. There is a function over here and we have to answer 3 questions, part A, part B and part C. Okay, so here we have a function that is y equals to 100 times 1.25 to the power of t. Okay, so the first question is, does the function represent exponential growth or exponential decay? Okay, here it is in the form of y equals to a times b to the power t. At the place of b, what do we have? So we have 1.25, which is greater than 1. Since the value of b is greater than 1, the given function represents exponential growth. Okay, so what is your initial value? Initial value is at the value we have at the position of a, that is y equals to a times b to the power of t. At the position of A, we have 100. So the initial value is 100. Okay, the next part of the question, part C is what is the rate of growth or rate of decay? So for that, we have to write the value of B as either 1 negative R or 1 plus R. So if the given function is exponential growth, then the value of B will be 1 plus R. That is something will be added to 1. If it is exponential decay, then something will be subtracted from 1. That is the value of B will be in the form of 1 negative R. So, but in our function, the value of B is greater than 1. So it's exponential growth. So this 1.25 should be written in the form of 1 plus 0.25 to the power of T. So here, what value is added to 1 inside the parenthesis? 0.25. So now multiply that 0.25 by 100 to convert that one to percentage. 0.25 times 100 is 25%. So it's already we have decided exponential growth. So the growth rate, our rate of growth is 25%. So this is the answer for part C. Okay, let's look at another example. Here we have a function that is y equals to 5575 times 0.65t. Does the function represent exponential growth or exponential decay? So the given function is in the form of y equals to a times b to the power of t. So at the place of b, we have 0.65. So 0.65 is the value between 0 and 1. So in this case, the value of b is between 0 and 1. Since the value of b is between 0 and 1, that is 0.65. So this is clearly exponential decay function. The given function represents exponential decay. Okay, what is your initial value? Initial value is the one we find at the position of A. Here 5575 is found at the place of A. So the initial value is 5575. Okay, now we have to find the rate of growth or rate of decay. So since it's a decay function, we'll have a rate of decay. So for that, we have to write this 0.65 in the form of 1 negative R. So okay, how can we find the value of R in this case? It's very simple. So what we can do is we can subtract this we can subtract this value 0.65 from 1. So when I subtract, let's write this one as 1.00. I'm going to subtract 0.65 from this one. So in that case, I'll be getting 0.35. So the given function can be written as y equals to 5575 times 0.65 can be written as 1 negative 0.35 to the power t. Okay, so whenever I want to find the value over here, it's very simple in exponential decay function. You just subtract the value of b from 1. Okay, even when I simplify this 1 negative 0.35, that is equal to 0.65. Okay, now the value which is subtracted from 1 has to be considered to find the rate of decay. So here it's 0.35 subtracted from 1. And to convert this one to percent, multiply by 100, then 35%. So the rate of decay is 35%. Okay, let's look at another example. The population of a small town was 3,600 in 2005. The population increases by 4% annually. Write an exponential growth function to represent this situation. And part B is what will the population be in 2025? Round your answer to the nearest person. Okay, here the value given 3,600 as initial value. In that case, so the corresponding value of t for 2005 will be t is equal to 0. So because we consider this 3,600 as initial value, but this is a population in 2005. Since 3,600 is the initial value and the value of t corresponding to 2005 is t is equal to 0. Okay, first let's write the exponential growth function. Okay, let me write the general form of an exponential function, that is y equals to a times b to the power t. So here a is the initial value. In our problem, the initial value is 3,600. And since it's exponential growth, actually the population increases. So it is exponential growth. Exponential growth means like the value of b has to be in the form of 1 positive r to the power t. So what must be the value for r? Is the growth rate. So the question clearly says the growth rate is 4%. That means the population increases by 4% annually. So every year the population increases 4%. So that 4% is the growth rate. So actually when I'm writing the growth rate in exponential growth function over here, it has to be in the form of decimal. So let's convert this growth rate to decimal form. So 4% can be converted to decimal by dividing 4 by 100. So percent means the given value is compared to 100. The ratio between 4 and 100. 4 over 100 is 0.04. So here it has to be 0.04 to the power t. So y equals to 3600, and the simplification of this one is 1.04 to the power t. So this is the exponential growth function which represents a given situation. Okay, in this exponential growth function, what if t is equal to 0? If t is equal to 0, then 3600 times 1.04 to the power 0. So since the exponent over here is 0, the value of this one is just 1. 1 times 3600 is 3600. So when t is equal to 0, I am getting the initial population 3600. And also please remember, t equals to 0 refers to 2005. And also one more thing we have to understand from the exponential growth function over here, y represents the population of the town after t years. Okay, let's answer part B. So the part B is to find the population in the year 2025. Okay, to answer part B, first we have to find the value of t corresponding to 2025. Okay, already we know that we know the value of t corresponding to 2005. So for 2005, the corresponding value of t is equal to 0. So for 2025, what is the corresponding value of t? Okay, from 2005 to 2025, how many years are there? So we have 25 years. So the same thing, we have to add 25 to here to the value of t. So 0 positive 25 will be 25. So the value of t corresponding to 2025 is t equals to 25. Okay, here to find the population in the year 2025. So in this exponential growth function, I have to plug in t equals to 25 and calculate the value of y. So when t is equal to 25, the value we get for y will give the population in the year 2025. Okay, let's do that. So y equals to 3600 times 1.04 to the power 25. So let's I think we can do calculation of this one using calculator. So and also we have to give our answer to the nearest person. So the nearest person is going to be 7888. So when t is equal to 25, we get y equals to 7888. So t equals to 25 means that represents the year 2025, and y refers to population. So the population in the year 2025 is in the small town 7888. Okay, here we can look at one more example. Actually, it's a exponential decay. Okay, let's go over the question. Your car cost $42,500 when you purchased it in 2015. So the value of the car decreases by 15% annually. So the value decreases. So clearly it's exponential decay. Write an exponential decay function to represent this situation. Okay, part A. So let's write the general form of an exponential function, that is y equals to a times b to the power p. Okay, so here a is the initial value. So initial value is the cost of the car when we purchased it. So 42,500 is the initial value. So that we have to write for a. And also one more thing we have to understand. So this is the value of the car in the year 2015. We consider this 42,500 as the initial value. Then the value of t corresponding to this year 2015 is 0. Okay, so and also now we have to consider the value of b. So for b we have to write 1 negative because it's exponential decay. So here we have to write the rate of decay. Rate of decay is 15%. So when I write the rate of decay over here, it has to be a decimal. So let's convert this percent to decimal. So 15% is equal to 15 over 100. So it is equal to 0.15. So the rate of decay is 0.15 to the power t. Okay, y equals to 42,500. So when I subtract 0.15 from 1, it will be 0.85 to the power of t. So y refers to the cost of the car after t years. Okay, so this is the exponential decay function which represents this situation. So in this one, if I plug in t is equal to 0, it refers to the year 2015. So then you'll be getting the value of y, that is the cost of the car initially. So if I plug in t is equal to 0, it will just become 1. 1 times 42,500 is 42,500, the same. So that's nothing but the initial cost of the car. If I plug in t is equal to 1, what will happen? T equals to 0 refers to the year 2015. T equals to 1 means it refers to the year 2016. 2015 plus 1. Okay, so when I plug in t is equal to 1, so y gives the cost of the car in the year 2016. Anyways, so this is the exponential decay function which represents a given situation. Okay, now we can try to answer part B. So the part B is to find the value of the car in 2022. We have to round our answer to the nearest dollar. Okay, let's do that. So for that, first we have to find the value of t corresponding to the year 2022. So for the year 2015, the corresponding value of t is t equal to 0. For 2022, what is the corresponding value of t? So here, calculate the number of years from 2015 to 2022. We have 7 years. So here also we have to add 7 to the value of t. So when I add 7 to 0, then I'll be getting t is equal to 7. So for the year 2022, so the corresponding value of t is 7. So in this exponential decay function, if I plug in t equals to 7, the value I'm getting for y gives the value of the car in the year 2022. Okay, let's do that. Y equals to 42,500 times 0.85 to the power 7. Okay, we can use calculator to get the value of this one. So let me do it. I'm getting 13,625. So when t is equal to 7, the value of y is 13,625. T equals to 7 means that represents the year 2022, and y refers to the cost of the car. So in the year 2022, the cost of the car is $13,625.